So we've talked about the concept of a system of more than two equations with more than two variables, but in this section we're going to talk about this applying to inequalities. So for example, let's say we have, we'll start with just the linear graph y equals 2x minus 5. Um, what this says is the points are on the line, like all the y points are going to be on this line. But if we had y is greater than 2x minus 5, then this says that the points are all above the line, 2x minus 5. Similarly, y is less than 2x minus 5 is going to say that the points are below the line, 2x minus 5. So we're now going to graph the equation y is greater than 2x minus 5. So when we draw the graph, we're going to first start by drawing our axes. It's going to be the exact same. And we're actually going to draw the graph the exact same as well. So the y-intercept's at -5. So we go down 1, 2, 3, 4, 5. And then the slope is 2. So we'll count 1, 2. So we'll count 1, 2 over 1. 1, 2 over 1, and then down 1, 2, then down 1, 2, and over 1, down 1, 2, and then over 1. So we're going to have this line. Whoops. The other thing, though, is that since it is greater than and not greater than equal, we're going to use a dashed line to show that the graph is not inclusive. So this line is going to be the boundary, basically. And so what this equation reads is that y is all the points greater than the line 2x minus 5. Greater than is going to be in this region right here. So we're going to show that with arrows pointing up this way. You can show that that's the region where it is, or you can just do some shading, and that this is the region where all the points lies. And again, the thing you have to notice is that this line has to be dashed to show that the points are not included on this line. So now we have two linear inequalities to graph. The first one is just 2x minus 5 again. So we're going to count 1, 2, 3, 4, 5 for the y-intercept. And for the slope of 2, we're going to count 1, 2, then over 1, then 1, 2, and over 1. And then again down 1, 2, and over 1. And then since it's not greater than or equal, it's exclusive, so we're going to show that with a dotted line, like so. And then this graph reads it's all the points above that line, so we're going to indicate that with arrows pointing above the graph. And then the other graph we're going to do is -1/3 x plus 3, so we'll count up 1, 2, 3. And then down 1 over 1, 2, 3, and down another over 1, 2, 3, and then up 1 over 1, 2, 3, and up another. Oh, that should do. And then we'll connect that with a solid line because that is less than or equal to, meaning it's inclusive. So we'll show this with a solid line. This graph should continue to show the intersection, and then so this will include all the points below the two. So the solution, or the graph of this system of linear inequalities would be this region here. So that concludes this section on graphing linear inequalities. So a good strategy when you're dealing with this system of inequalities, especially more than two, is to label with arrows where the region is included, and then you can shade the whole entire thing quicker once you've drawn all the graphs.